Hey guys, so you see, what I wanted to talk about today is very necessary to understand the code progression. So if you see when a program starts running, you can assume that it starts with one process, right? The main function. Whether it's in Java, Python, or any other language, there will be an entry point to the program, right? In Java, it's the main. In Python, also we can have a main method. So you see what happens. Line 1 comes in, line 2 comes in, line 3 comes in, and then in line 3 you decide to split away. You start a for loop, right? You see, this is how you need to think agile. This is how you need to think the algorithm is a progressive process, right? You did a for loop, you're gonna count it in this way, and then in this for loop again you have a line, another line, another line, right? And now this, you see, even the diagram tells you what is happening. So it's gonna come here, it's gonna come here, it's gonna come here, and then here you again decide to have an if condition, and this if condition will have this line, this line, this line. This is an if condition. I'm gonna signify it by this. Just I'm trying to signify it by this diagram to show you the progression and how we can think. You see, now I'm trying to put it in perspective of a metaphor, right? Or visual. Visual is very good for us to understand and to visualize the whole process, right? And then again, this code, you see, this distance is much bigger than this distance, is waiting for this to happen. If it happens, if this condition is met. If this is an if condition, some condition should be met so that the code can enter here, right? This is a line for an if condition, right? This one. And this is these are lines under the for loop, you see. So then what happens is, then finally you come to the end of the function, right? This is how it's done. Now if you look at in here, this is a for loop, it goes in here. Once this is done, this for loop is done, it will return back to this line, which means it basically returns to here. You can think it in both ways. Takes this result, whatever calculations you have done, comes in here, comes in here, comes in here. If condition is checked, if it's met, good to go, this is going to be done. If not, we're going to go in here. Metaphorically, you can think in here as well, and then the end of the function. Now what happens is that the return statement right here, you might have a return statement. You might even have a return statement in here, right? Based on certain edge case, you might just put a return statement in here. You might have a return statement in here. You might even have something in this line. You might have an if condition, right? We signify by this, which will have its own line of code, variables, initiations, list, any kind of structure that you are thinking, right? So, and then here you might think, check something, and you might just tell the function don't go forward and just return this, return from here, right? So now, for example, this this one is waiting for this to happen. Now this is waiting for this block to happen, right? I'm just telling you the progression. If we have a for loop in here, just imagine here we have a for loop, right? This is a for loop, and here we have one line, 2, 3, right? This is a for block. Now you see, this is the complexity is telling you. You see what's happening is, this is a linear time complexity. This is the number of inputs and this is the time. Now the more inputs grows, the time grows. Now you see this, what happens to this one? It's order of n squared. So the graph of the n squared is like this, right? Time grows twice of the size of the input. Even the diagram is telling you, when we come in here, this is gonna run n time, but this is gonna first run. This is gonna run in n time, and then when this n is done, multiply by this n is n to the power of 2, and then you go ahead. How many number of fors that you have in here, even if you have here a for loop or here a for loop, these are all running in n amount of time, right? This is n, so it's like n plus n plus n plus n plus n. Even if it's 1000 n, we can ignore 1000 and this is still n. This is how the code runs, and you can take the progression as you want. You need to think about it. Certain conditions, it's an edge case scenario as well, right? You might just have a condition in here, either you return a value, right? Either you return a value, or you say, you know what, if this didn't happen, then just go ahead and do kind of this logic. You can move as much as you want, as much as you want. You might even do a calculation in here, right? Certain calculation, resetting certain values. Now you see, whatever is in here, whatever is inside this block, let's suppose if this is a for loop, right? And whatever is inside that for loop, it's not accessible outside. You see, it's even telling you. Now this for loop, whatever is here, variable initiation, list initiation, data structures, what not, this is not accessible outside unless you're changing a value which is initiated right here. If you're changing this value inside this for loop, this is accessible here, but this is not accessible here, right? The parent is the boss. The boss can access whatever is in overall the program, but these are the children, or these are the minimal values that cannot. And that's why while writing algorithms, we try to not have situations where we are constantly going and initiating for loop inside for loop, for loop inside for loop, because you see what happens. If I have a situation like this is happening in n, this is happening in n, this is happening in n. First of all, think about it. First of all, this should happen. Then for each value of this all should happen. Then for each value of this all should happen. For each value of this all should happen. And then this will happen. You see? From here we come, then here, here, and finally you are going here. Loop condition, right? So that's why we always plan to have at least one loop in order of n times. We can even increase the complexity of the algorithm even better than this, an n log n or other kind of another faster algorithm, constant order of time, and through dynamic programming and other kind of techniques. But this is the general mechanism. We're going to do next is maybe try to simulate it and see how it works. Thank you.